Hi students. Okay. Good morning all. Okay. Today we'll go with the new topic that's we call the kmap. Okay. Kmap is nothing but corner map. Okay. Corner map. This is the one of the scientist name. Okay. Corner. He has given the some solutions to the simplification of the Boolean function. As you all know, the simplification of the Boolean function will be done with the from the Boolean laws. Okay, that's the Boolean theorems and the postulates. What is the necessity of the simplification of the Boolean function? Yes, as I already taught you in the last class. Yes, no? In the last lecture, I already taught you what is the necessity of the simplification of the Boolean function. Okay, as you all know that as an engineer, as a scientist, he might be having the lack of the knowledge of the designing of the these logics, okay, logic designs. Okay, he might be designing the some basic logic design with the repeatedly. Okay, repeatedly. It might be clumsy, and also he has the lack of the knowledge. He might be designing the somewhat complex. Okay, in order to overcome that one, that will give the time, and also it is the cost effective, and also will give the some cost effect. Thereafter the efficiency also less. Okay, in order to overcome these problems, first is the cost and time consuming, and also this is what here the efficiency also gets reducing because of the lack of knowledge by the developer. Okay, who is designing the logic gates with the logic design. Okay, this logic design can be simplified with the help of what here the some theorems and postulates. This is to be done given by the one of the scientists whose name is what in his Boolean. George Boole, you know. Okay, he has invented the computer as now. Okay, the George Boole itself, he has given the some more theorems and laws, some postulates regarding the in order to simplify the Boolean function. Okay, let me have the what is the necessity of Boolean function, you know. Yes, then we'll go with the what's the kmap. Okay, the Boolean function, what is the necessity of the kmap itself? The Boolean functions to be reduced are simplified up to the three variables by the Boolean theorems and the postulates. That's the Boolean laws. It's to be, we can't to go with the two variables can be simplified with the Boolean laws, and that's the Boolean theorems and the postulates. And three variables also we can simplify with the help of what here the Boolean laws. Okay, in order to, if you go with the more variables like 4 variables, 5 variables, 6 variables with the in the Boolean function, that is to be simplified by whom? By the another method we call as the Carnot method. The Boolean function can be simplified by the Boolean laws that done by with the help of what here the Boolean laws up to 3 variables. But if you want to go with the more than 3 variables, that is to be done with what here the Carnot map. Carnot has the kmap. In simple form we call it what here the kmap. Okay, that's because as the kmap. This kmap can be, okay, we can solve up to the more than 3 variables. So, okay, Boolean function can be simplified with the help of the Boolean laws up to 3 variables. If you go with the more than 3 variables, then we go with the this is to Carnot map, kmap. Okay, kmap, in the kmap itself we have the 2 variables kmap, 3 variables kmaps, 4 variables, 5 variables, 6 variables. For your syllabus we don't have the 5 and 6 variables kmap, up to 2, 3, 4 variables kmap we need to. What's the kmap? Next is what question is what is the kmap? It's the pictorial representation of the, it is the pictorial graphical representation of what is the truth table. Whatever the truth table we have now, that's to be have the some values x and y. The two values 0, 0, 1, 1. These are the binary combinations for the two variables. This is to be transferred or completely transferred rows and column to what in the form of what is the grid form is nothing but this sometimes we call as the grid or kmap, grid or skeleton. This is called as the skeleton or grid or map. Skeleton, grid or map. Okay. These three names to be called by the to call to what here the kmap. Yes, these are the boxes. This is the boxes. This to be called as the boxes or the box, and also we call as the sometimes cell, and also sometimes called as the squares. But I'll be using always with the cell name. We can say that this box, this is to be cell or box, and also square, so we call it cell. Okay, next we'll come with the, we have the, this is to be what here the, these are the rows, this is to be column. How many rows are there? and 2 columns are there in the truth table. Similarly, here also we have the reduced to be what is the 2 rows 2 column. How 0, this is to be taken the x on the row side, y on the column side. X can have the two values 0 or 1, that's to be x dash x. Y can also have the two values, that's to what are the 0 1, that's to y dash y. Got it? Next, indexing of the cells. How indexing of the cells? Okay, that's to be done with the 0 1, multiply the row with the column. Row 0 is what having 0 1 is what having 1, 1 0 is what having 2, this is what here the 3. 0 combination is what here the 0 combination is what here the 0, that's to be what here the x dash y dash. X dash with the y, x dash with y is what here the x dash with y is what is the its equivalent value is 1. Okay, similarly x multiplied with y dash is what is x multiplied with y dash, that is to be what is the x multiplied with y dash is nothing but the 2 here 2, that's to be written with the 2 indexing. X, then I multiply x with y, x y, this is called as the x y, this is one portion, this is the higher, this to be called as the 3. Okay, this is called as the indexing of the cells. Whatever we have the cells in this one, these are the called as the terms. Okay, these are the terms, we call as the terms. The Boolean combination we call as the term. Okay, this is to be what here the terms are mean terms if it's a SOP type of function. If it is SOP type of function, this is all about the kmap. Okay, this is all about the kmap. Okay, after the giving the rows with the columns and also indexing of the cells and also filling the mean terms, this to be done with next is what the simplification, grouping of the cells. Next is what is the grouping simplification. Okay, this is the Karnaugh map. What is the necessity of Karnaugh map means what is the we can reduce the human errors. Okay, in the earlier classes we have seen the while reducing the Boolean function with the help of Boolean laws, that is Boolean theorems and postulates, we are making the so many mistakes over there. We are making these so many mistakes. So that can be avoided with the help of the what is the K-map designing. Okay, those okay, there we are using the some laws. Okay, from identity law, distributive law, those laws itself we made what is the K-map rules. Okay, I will tell that, and also some low rows and columns in the truth table that is to be transferred in the form of grid form. This is all about the K-map. Okay, this is not a complete K-map. This is for the two variables K-map. For introduction purpose, I given the how to write the K-map for the two variables. Similarly, we have the 3 variables, 4 variables K-map also. Okay, first we are consider the 2 variables K-map itself. Okay, let me have the one example over this one. For this one, okay, let me have the one example for this one. Okay, let us to be he has given the examples. Okay, for the examinations. Okay, the question might be asking the like this. You will be asking the questions as the Boolean functions to be what are the different types. Okay, with the in the form of K-map you would be asking, or else you would be asking in the form of what are the even the with the help of the in the form of variables also. Okay, that's what are the we will be discussing one by one. Okay, first one will consider the first one to be considered here the first one is here the K-map for the 2 variables. Okay, the first question would be on this one K-map okay, for 2 variables. Okay, you might be asking in the form of what with the help of truth tables. Okay, truth tables, these are the 2 variables because of the 2 variables K-map is here, 2 variables x and y, x and y. 2 variables can be variables means what 2 to the power of n number of combinations, that's the 2 variables. N is what is the number of variables, how many? 2. Okay, 2 to the 4 combination of the inputs I have here. Which are those 4 combinations? Those are the equivalent to the decimal 0 1 2 3. Okay, that's to be 0 0 0 1 1 0 1 1. He is might be asking the directly truth table. And also he has mentioned with the you might be giving the problem with the some mean terms, like the function with the terms as the here the this is to be what 1, this is to be what here the 1 only. Okay, 1. Okay, this is to be what is the 1. Remaining cells also remaining combination as 0 0. Remaining combination says 0 0. Okay, as you all see this one, this is the he has given the truth table with the binary function with the having the which are those terms. These two are terms are the these 2 terms are the mean terms here. The okay terms here. Okay, this is nothing but we are the what we are solving the what are the solving here the this to be okay what is the function which is having the same. Okay, Then the can I write with the function with here the f of x y. Can I have the function with here the wherever the 1 is there, that is to be considered as the term in my Boolean function. Boolean function. This is to be what here the 0 0 0 0 is what is the x dash y dash plus this is to be what is the x y, because y dash, because the x is having the high value here. This is the x, y is having the 0 value, that is what we call the y dash. Yes or no? This is to be here the two terms we have. Okay, that's called the mean terms. In the we are whatever is solving the with the SOP form. Okay, SOP form only. Let me consider the later with the, what is the type of that one I will teach you. Okay, then the then we have already seen this one, f of x y can be written is what, this one is what here the 0 0 is the m0, this is what here the m2, this is the m0 m1, these are the mean terms combination SOP form. Then this to be written as the summation of this one 1 m0 m2. Okay, this is the summation form, because I am taking this one outside. Then the summation of I am taking the m as the outside. This is 0, this is 2. Okay, this is what is the f of x y. This is the f of x y. Okay, then we got the from the Boolean function we got the sum equation. Okay, this is the SOP form. Sum of products. I will teach you that one. Okay. As we already discussed this SOP, what is the SOP? What is the POS in the last classes? Okay, we am taking considering in the form of SOP. Okay, now the combination of these two forces is here. The which are those? This is the two variables kmap. Okay, how many cells I need here? 2 to the power of 2 means 4 cells of kmap I need here. Okay, then the row side I will be taking the x as the row side, y as the column side. Yes sir. Okay, then the take this as the x as the 0 1, this is 0 1. Yes or no? Yes. Okay, this to be x, this to be x can 0 can be written as the x dash, this 1 can be written as the x, this y 0 can be written as the y dash, this will be written as the y. Yes sir. Okay, then the indexing of the cells. Okay, indexing of the cells 0 0 is that 0 0 1 is what is the 1 1 0 is what is the 2 1 1 is what is the 3. Yes or no? Okay, how many are there in mean terms? 0 2 cells. 0 is where is that? 0. 2 is where? Here. Okay, remaining cells should be what replaced with what? Replaced with 0. Then go with the grouping of the cells. Grouping of the cells depends on the number of cells, okay, which are the adjacent to each other. Adjacent to each other. This is the adjacent to each other. These two cells are adjacent to each other. First, I have to see which one, if 4 combination is possible or not. First, you have to check the 4 combination. No. Okay, 4 cells are there. Maximum is 4 cells. If it is not there, then go with the 2 pair cells. Quadrant pairs of cells possible. Otherwise, one can be also single is also possible. But here the pair grouping is possible. Pair grouping is possible. Then the okay, then done with the pair grouping. Okay, then the combination. Okay, then simplify this group. Okay, with the help of the rows and column. In the row side, this group belongs to how many rows? How many rows this belongs to? 2 rows. Which are those? First one, second row, first one, second. That is this variable is to be not considered. Okay, because the kmap rules. Okay, some kmap rules are there. That's to be what here if any variable is changing its state, then don't consider in the while writing the mean grouping. Okay, that is called as the x. Then don't write this one is to be considered as the 1. Then come to the column side. This belongs to only one column, that is called the y dash. Then the output is what here the f of x y equals to y dash is there. Whether we got the answer properly or not, we'll check it. Okay, while we're simplifying this Boolean function with the Boolean laws, because we have the 2 variables. Boolean laws can apply to up to the 3 variables, but this is the 3 variable kmap. Okay, we can apply this one whether we got the correct answer or not. Here the which one is y dash is common here. Yes sir. In these 2 terms, y dash is common here. Take the y dash as the common. Then we left with the x dash x plus x dash plus x. X dash plus x is the identity law by applying this is x dash plus x is what is the 1, that's nothing y dash. So we got a whatever we got the answer from the kmap, and even the simplification of the boolean function of the booleans are same because of the applying the same for the because of the two variables. This is all about the two variables kmap with the simple techniques, with the very simple techniques. We'll see the one more example. Okay, I hope you all copy this one.